Okay, so before we go on to the next topic, let me first discuss to you this formula for the differential of logarithmic function. So we have here the differential of the logarithm of u to the base a, that is equal to derivative of u all over u times the natural logarithm of a. Okay, so when we say natural logarithm, that is actually equal to the logarithm of, say, for example, u to the base. Ang base niya is e. So this can be rewritten as the natural logarithm of u, or ln u. Okay, so this is the general formula for the logarithmic function, for the differential of the logarithmic function. Say, for example, if you have here um, the differential of ln u, diba? Ln u, take note that when we say ln, the natural logarithm of u, this is actually equal to the logarithm of u to the base e. Yung e ang base niya. Okay, so this is actually, these two are actually equal. So this is equal to, if we apply this formula, this would be the differential of u all over yung u times the natural logarithm of e. But since the natural logarithm of e is equal to 1, because according to the property of logarithm, suppose you have a logarithm of, say, for example, 5 to the base 5, if the argument of the logarithmic function and the base is equal, mag-equal nga ni iton here, then this logarithmic function is equal to 1. So another, if you have logarithm of, say, 7 to the base 7, this is equal to 1. So ini nga ln e, this is actually equal to the logarithm of e to the base e. So magpareho nga ni an argument han logarithmic function and the base, then this is equal to 1. That's why this quantity here, this will be equal to differential of u all over u, because ln e is equal to 1. So therefore, ang derivative, ang differential of ln u is equal to differential of u over u. Yan. So this is our formula. Okay, so ito yung titingnan nating formula, dalawa lang. We have here the logarithm of u to the base a, and of course the natural logarithm of u. Okay, before we go on, let me just present to you the different properties of logarithm, because this will help you a lot in simplifying complicated logarithmic function. Okay, so yung una, so if you have a logarithm of u to the base e, o ibig sabihin yan, if the base is e, then you can rewrite this as the ln, the natural logarithm of u. Yan. Another one is that if you have, say, for example, a logarithm of b to the base c. Yan. You can rewrite this as the logarithm of b raised to a to the base c. Okay, so parang yung numerical coefficient of the logarithmic function will be can be written on the ano, as the exponent of its argument. So naging exponent siya ng argument, which is the b. Okay, so you can rewrite that. Okay, also, if you have, say, for example, the logarithm of, say, a to the base, say, 5 plus the logarithm of b to the base 5. So, you can, this property, you can only apply this if and only if both of the logarithm have the same base. So dapat magpareho yung base niya. So in this case, yung base nila is 5. So if they have the same base, you can rewrite this as the logarithm of a times b to the base 5. So kung plus dito, multiply dito. Okay? And conversely, if you have say the logarithm of a to the base 5 minus the logarithm of b to the base 5. Kung minus naman, instead nga multiply dito, this will be the logarithm of a over b to the base 5. So, magiging division naman kung minus din here. Okay, so Yun, that's what I want to ano, for you to know, because sometimes you will be given a complicated logarithmic function pero pwede naman pala i-manipulate to make it easier to differentiate or easier to integrate. So you should know these properties of logarithmic function. Okay, so next. Okay, so I'll just put here the differential of logarithmic function for our reference. Let us have an example. We have number 1. We are to get the differential of this function. Y is equal to ln 2x plus 1. So this is our function. So if we want to get the differential of y, we'll both get the differential of both sides of the equation. So this will be ln 2x plus 1. Yeah, so this is our working equation. So simplifying this one, applying the formula for the differential of ln, natural logarithm of 2x plus 1, we'll use this one. Diba? So the differential of ln u is equal to du over u. Take note, our u here is 2x plus 1. So we'll differentiate the u, which is 2x plus 1. This is differential of 2x plus 1 all over 2x plus 1. Yan. Simplifying this one, we'll have differential of 2x is 2 dx all over 2x plus 1. This is our value for dy. So this is our answer. This is the differential of the function y is equal to ln 2x plus 1. Okay. Let's have another one. Let me just erase this one first. Okay, so another one is we have here y is equal to the logarithm of x cubed plus 2x plus 1 to the base 5. Yan. So the argument of the logarithmic function is x cubed plus 2x plus 1 and the base is 5. So to get the differential of y, we'll get the differential of both sides of the equation. So this will be differential of the logarithm of x cubed plus 2x plus 1 to the base 5. Yan. So for this one, we'll use this formula right here. Okay, so yung dy natin is equal to, according to here, differential of u, and take note our u is x cubed plus 2x plus 1. Diba? Differential of u over u times the natural logarithm of the base, which is a. Okay, so this will be, just following this formula, this will be the differential of our u is x cubed plus 2x plus 1 all over u, which is x cubed plus 2x plus 1 times the natural logarithm of the base, which is, yung base natin is 5. Yan. So simplifying this further, this will be differential of x cubed plus 2x plus 1. This is 3x squared plus 2, right? Times dx all over, this will be x cubed plus 2x plus 1 ln 5. And so this is our answer. So this is the value of dy. So this is the differential of the function y is equal to the logarithm of x cubed plus 2x plus 1 to the base 5. Okay. Let's have another example. This time we have the logarithm of cosine x, yan, to the base 2. So the argument of the logarithmic function is a trigonometric function. So we are to find for the differential of this function. So paano man? So this is equal to, your u is cosine x. So the differential of cosine x, this is according to the formula, over u, which is the cosine x, multiplied by the natural logarithm of the base, which is 2. Yan. So simplifying this further, this is the differential of cosine, that is negative sine x dx all over the cosine x multiplied by the natural logarithm of 2. Sine over cosine, sine x over cosine x, that is tangent. So this is equal to the negative tangent x dx all over ln 2. So this is our final answer. So madali lang, di ba? Madali lang. You just need to memorize the formula for the differential of logarithmic function. So dalawa lang naman. Or you can just memorize this one since ito naman, this is just derived from this formula. You just need to remember that when you say the logarithm of the natural logarithm of u, this is actually the logarithm of u to the base e. Yan. So kaya nagkakamaya nakitahin natural logarithm because of this number e. Okay, so that's all for this video and see you next time.